Well, by definition.
By definition, I guess. And just say, okay, so let this be. Right, yeah, okay, yeah.
Satisfies the definition.
Yeah.
By definition.
It's like, is a linear extension a linear map? Well, maybe. I guess you got time to go back and prove that other thing if you want to, Daniel, because we still got about 8 minutes. You said you wanted to do that. You're itching to do it.
I mean, it's not that exciting, but I just thought it, fit together very well.
Yeah, okay, so I know it's out of order, but theorem 2.4, you can go back and do that now.
I won't rewrite it since it's 3 parts.
Oh, no, that's fine. You can just jump into the proof. It's the... I will reiterate they were the equivalence for a set of ordered points in Rn of affine independence of P0 through Pm, that if you take any linear combination of them equal to 0 and the coefficients sum to 0, then the coefficients are all 0, and then that case 3, the uniqueness of the affine expression. So, anyway, so you're going to start with 1 implies 2. Okay.
Yeah, so assume that the sum of these coefficients is equal to 0, and that the sum of the coefficients times the points is also equal to 0.
So you had the timing all worked out. I'm sorry I rained on your parade. You could have had this, we would end right on time. It would have been all pretty and just perfect, and look, I messed it up.
Look what you did. Right.
It's just a permutation.
Just a permutation, yeah.
So what we're trying to show is that each of these is going to equal to 0.
No one knows what that means.
So we have that. So 0 equals sum of SI pi, which is equal to sum of sum of SI pi minus sum of SI, which is equal to 0, times P0, which is equal to the sum of SI times pi minus P0. This is I equals 0 to m, but it's also I equals 1 to m because I equals 0 just makes it 0. But what did we say about affine independence? It means that all of these are going to be linearly independent. So SI times pi minus P0 equals 0 again, which tells us that S1, S2, Sm is all going to be equal to 0 by definition of linear independence. And to show that S0 is 0, it's right because, and since the sum of all these is 0, so sum of Si equals S0 plus sum of I equals 1 to, Si, which is equal to S0, which is minus L equal to 0. So, alright, and then for 2 implies 3. So now we assume that if this is true, then each of these s's is going to be equal to 0. Okay, so we let x be an element of A, and assume that there are 2 different ways that we could write it. X is equal to the sum of ti pi, but also the sum of ti prime pi, with each of these, sum of ti equals sum of ti prime equals 1.
Okay.
Therefore, subtract both of these, we get 0 equals sum of ti minus ti prime times pi. Yes, but also sum of ti minus ti prime is going to be equal to sum of ti minus sum of ti prime.
Mm-hmm.
Which are both equal to 1, which makes this equal to 0. So therefore you have this linear combination of pi's with the sum of them being equal to 0 by 2. That implies that ti minus ti prime equals 0 for all I. And therefore each of these coefficients has to be the same.
So there's your uniqueness.
Yes, and then
Hmm.
4, 3 implies 1.
Let's see
Right
here.
here.
So what did you're using that was 2 implies 3?
Using, okay, so we have
Just now,
this,
right?
yeah,
Yeah.
yeah, okay, so,
Excuse me.
right, okay, so now we're gonna assume, okay, so we
okay.
have that for all x, there's a unique combination, unique set of TIs, right? Expression. As a affine combination. Okay, now we assume that gonna do a contradiction. That this is gonna be affine dependent. Therefore, the set of P1 minus P naught all the way to PM minus P naught is going to not be linearly independent. Okay, so let's see. Yeah, so that would mean that there exists some. Okay, so there exists so we can write 0 as sum of Ri times Pi minus P naught with not all Ri's being 0. So with, some Rj different than 0. Okay. And so we can divide all this by Rj to have the coefficient in front of Pj minus P naught be equal to 1. So we can write, so we can just assume that Rj equals 1. Okay, so we have two different notations. We have Pj is equal to 1 Pj, right? But we also have Pj is equal, actually I'll derive this. So we have that. Okay, right, okay, so Pj is equal to the sum, where I is different than j, of Ri times Pi minus P naught, plus Pj minus P naught, because we're assuming that Rj is equal to 1. This, so 1 times this, which is equal to the sum. Oh, I'm sorry, this is equal to 0. Therefore, Pj is equal to minus sum of I different than j, Ri, Pi minus P naught, plus
So you're
Plus-
supposing linear
plus P naught,
dependence. So you're like, so if it's not linearly
Okay.
independent, it's linearly dependent. So you, without loss of generality, suppose that you have 1 for the Ri coefficient there,
Yeah. Rj.
and that, or jth, okay.
Okay, so now I'm solving this equation for Pj, so I'm moving all this to the other side.
Okay.
Splitting this one up, so you got minus sum of Ri Pi, plus sum of Ri P naught, and plus P naught,
Uh-huh.
which is equal to sum I different than j, Ri Pi, plus 1 plus sum I different than j, Ri P naught. Okay, but this is a combination of
So you found a different
combination, and so
a different set of what are they called? Coordinates.
yeah, coordinates, and so
So you had the 1 for Bj in the first one. Now you got all this Ri and 1 plus sum of. There's not even a Pj there, so like you have the jth coefficient is 0, I suppose. Well, wait, no. Is there no Yeah, there's no J, right? There's no PJ in that expansion you have there.
Right, yeah, right. So you get like some different than J, Ri, plus
So
some of this is
So
becomes
that's-
an affine combination.
so that's your
So these are two different.
Oh,
this
you
is
need-
an affine combination. This
yeah,
is,
I'm sorry,
and
I
this is
forgot.
also an
You
affine
need to show it's an
combination.
affine combination before you can capitalize on your contradiction, right?
Right.
Yeah.
And so
Why is that an affine contradiction? Why?
this is a minus.
Yeah.
Okay.
Oh, okay. Well, there you go.
that makes it a lot easier. Yeah.
The minus kind of
I
matters.
was a little
Yeah.
bit confused. Yeah. Okay. So
Okay.
two different affine combinations. That's a contradiction since we assume that it's unique. Therefore, these are affine independent.
Excellent.
Yeah, that's it.
Very good, Daniel. Thank you for doing this. It was much easier for me today. I think we may always do this in the future. God, this is living.